Alright, yeah, welcome back again. This time around, we want to look at some of the tests for parametric tests. Assumptions rather for parametric tests. Last time we discussed some of them theoretically. We are talking about normality check, Toya check, talk about also variance check, and also independent check. But there are two basic ones I want us to look at under this section. Though this one will cover one today, and that one next time, which is a normality check. It's very important. So, of course, we don't need to meet all the assumptions of parametric to perform a parametric test. Okay, I told us parametric is robust. I don't need to meet all the assumptions. So at least you have to meet some assumptions. You cannot violate all the assumptions. If all the assumptions are violated, then you have to switch out to normal parametric. All right, so one of them is called normality check. To check if our data is normally distributed. This is a Gaussian approach. Okay, we are going to use our Iris data set. Okay, data set we're going to use that. So it has a 4 columns, 4 numerical columns, and then one categorical columns, which is a species. All right, there are three groups in the species, 3 groups. All right, there are separ length, okay, separ width, beta length, beta width. So these are the 4 columns that we have there in there. If you are familiar with R, this can always in R, come along with R programming. So, I think it come along with also Python also, and even I've seen it also in MATLAB. So it's a very popular data set that come along with MATLAB, Python, and R. So, but this is actually a bit from R environment before other data set begin to make use of it. So we want to copy this onto our our past environment now. Just select all copy. Okay, copy all. Everything go to our past. As usual, just let this paste here. Right, so paste. Control V, paste. Okay, and you can make this one good if you want for now. I don't think we need it for now. All right, so now we want to look at how to check our normality here from these columns, numeric columns. Don't forget numeric columns. So they want to check if the data is normally distributed. So let's start by the first one. This one, separ length. We want to check if this separ length is normally distributed. Let me maximize separ length. So the first thing you need to do is check what to use. First one is to use a Shapiro test first. Okay, to check if data normally distributed. So we go to univariate. We click on the normality test here. You can see normality test under univariate. Right, so I click on it. So my concern is Shapiro test. Okay, that's my concern, Shapiro test. All right, so here is this one is 0.01, which is already more than which already less than 0.05. Don't forget, if you have followed me carefully under R, you understand that the hypothesis of Shapiro is inverse to normal hypothesis. All right, both Shapiro and Levin test, Anderson, and the rest of them they are inverse, which means that if your data is less than 0.05, it means it fails normality check for Shapiro. It fails. So your p-value rather must be higher than 0.05. That's what it means. It must be higher than 0.05. So if it's higher than 0.05, then it means it's passed normality check. That means the data is close to normal distribution. That's what it means. So let's we can agree together that this data is not normally distributed. It's not. Okay, it is not at all, because looking at this now, we have 0.01, which is less than 0.05. All right, so same thing happens to this also. Let's look at this. All right, this seems to pass 0.1. Okay, 0.1. We are just concerned about Shapiro for now. Okay, don't want to drop ourselves with other ones, so our focus is Shapiro. All right, so we have a 0.1, which is more than 0.05, which means this one pass normative test. You can also do them together actually, so that one by one, right? You can see them together. Let's do them together. Go to univariate normative test. Just hold on, it's loading. Right. So now we can enlarge and see the result. You can see here. So each of them. All right. So only for Shapiro, only separate the thing which we saw now at the past. Other ones are very high, very high. This one are very significant. So they tell me they failed Shapiro test, and this one also, but only separate with that passed. So this is just a statistical test to confirm if your data is normally distributed or not. But that is not the only thing we are going to do here under this section. I'm going to also perform other tests later. So, but this session, I don't want to make it too long. For this, you have to test normative check, which is Shapiro. We're going to use graphical output also to do the same. So let's just stop this here for now, and we'll continue from there in the next. Thank you so much for listening. I will see you in the next class.